Well, hi, good morning. Thank you so much for joining me here in my shop. I think it's time to take a big leap forward with this CB radio and start examining the transmitter side of it. So on the receiver side, the very last thing I determined is, wow, it's pretty questionable about just which channel this radio is receiving when you select the different channels, even though quite clearly the crystals are marked channel 5, 13, and 15. Certainly my experimenting in here has suggested that those crystals are no longer accurate. Now, I read up on crystals a little bit. I think what I read will apply to the crystals that are inside this radio. The crystals are extremely stable, of course, and we use them in watches to keep track of time and things like that. They do have an initial drift period after being manufactured because of various manufacturing issues that are unstable in themselves, and it might be a 1 day, 2 day, maybe as long as a 60-day period over which the crystal settles into its housing and all that kind of stuff. Even that drift is in the range of 1 part or 2 parts per million, which is a very, very small amount. So, in the case of crystals used in a radio like this, a typical manufacturing step is to operate the crystal or operate the device for a period of time to run in the crystals before doing some kind of alignment. That's all factory stuff. Once the crystal is out in service, once it's 10, 20, 30 days old, if it's going to drift at all, the drift will be hardly anything. So over the life of this guy, from my reading, I think a crystal might drift 1 part in a million over the life of this thing. So what is that? Now, 1 part in a million. So this is oscillating at 27 million cycles. 1 part in a million is 27. That's 27 cycles out. It's nothing. It's nothing at all. So why this is off, if it is off, if I'm correct in my last testing, if it really is off, why it's off, I don't know. As far as I know, crystals are really locked onto their frequencies. You cannot push them far at all, this way or that. So can you push it all the way from one CB channel to another? Wow, I don't think so at all. So there's a little bit of a question about what's going on with the receiver side, and in thinking about this, I realize there's another set of crystals driving the transmit side. Now, what's happened with those? Could it be a receive side is drifting one way and the transmit side is drifting another? Could it be I'm going to receive on channel 12 but transmit on channel 14 without knowing it? So these are the questions I want to try to answer right now and settle this issue down. If, for instance, this thing receives and transmits on 2 different frequencies, how could I ever possibly put this thing to work? And the last thing is the attempt I made at adjusting the frequency, the crystal oscillation frequency, trimming it. Maybe I did that wrong. Maybe I picked the wrong control. Maybe I made a mistake there, and that's why it didn't have any effect. I couldn't find any information about how much you can work a crystal frequency back and forth, but my guess is it's not much at all. Okay, so how are we going to figure out what channel this thing's transmitting on? I have a couple challenges with that. I'm receiving on. Probably the easiest way is to use a variable frequency generator and just rotate and identify the frequency that this thing's receiving. That's probably the best way. Another way I was thinking about was to make use of my in-shop walkie-talkie here and just run through the channels on the walkie-talkie, transmitting on each one and seeing what's happening over here. I think there's some problems with doing that. Not the least of which is, how do I know my little walkie-talkie over here, right there, on channel 10 right now, how do I know this thing is correct? I don't. The most certain thing I've got going in here, really, is my inaccurate frequency counter, which I usually say is two counts off, but it's also got a percentage type error or part per million type error in it. So I very seldom am I running this thing way up at 20, 25 megahertz like I am now. So it turns out that error is a little bigger. It's no longer one or two numbers here. It's got to be bigger. So even this starts becoming questionable. So another thing I have as a frequency standard is what shows up on my SDR radio. The SDR radio also has precision problems or accuracy problems. It's extremely precise, but accuracy, it has its issues too. So in the end, maybe I better come back to something that's crystal controlled. What would that be? Well, I'd be right back to this thing being the standard. This guy's correct, and everything else in here is wrong. So this is why I'm a little unsettled and declaring this radio receiver to be off channel. So I'm going to go through these things. First on the receive side and try to clearly identify what's up. Get a notepad ready here because I have the feeling notes are going to be in order on this. Okay, now I still have a connection into the AVC here. I'm probably not going to throw the receiver off at all, but we can double check that very quickly once it's operating. In fact, let's get this guy going here. There he goes. And we'll start him on channel A. And I'll start making notes here. Channel A. On the transmit side, if we manage to make it there today, I do have this guy here, and I've got his brother here. They're both doing, well, they're both Micronta. This must be the older one here. Yeah, they managed to reduce the number of buttons down to next to nothing. It has a little antenna, a spot here, I think where you'd have a little antenna sitting up, and it says FS antenna, field strength antenna. So that's kind of interesting. This might work as a field strength meter. Maybe I should put this one in line, put a little antenna on here and have this one sitting. Yeah, that's a good idea. I will do that. Okay, radios appears to be operating fine. Let's give it the full works. It's currently switched on the antenna. So I believe, let's just check. Sure. Yeah, sure. On the antenna, no doubt about that. One of these days I'm going to turn this radio on and stuff's going to come out of it. I mean, people's voices are going to come out of it. Yeah, stuff's going to come out already. So, next step. I think signal generator running through each one of these, identifying its receive frequency. So channel A, we're all set. Let me just switch my location of this. Okay, over to the signal generator. The feed is into the antenna here. Everything is good to go. So channel 5, let's not even look it up, let's find it here. Okay, let's find it. Let's look it up, see where it's supposed to be. Hey, how come you're not coming? There he is. You know what? That was the walkie-talkie on the wall. So that's the walkie-talkie. The walkie-talkie's on channel 10. This is on channel 5. Let's go down. Anywhere in here now. Volume up. Squelch. Down. I triggered the walkie-talkie with no direct connection. This is fed right in the back. Wow, I'm down to 26.5. Okay, let me check the frequency here because we appear to be shooting in the dark at the moment. I have a nice chart here handy. Channel 5, 27015. I should remember that. 27015. Look at that, was the radio that time. Okay, how did I miss it? Just went a little too fast maybe? 27005, but really channel 5 is actually 27015. So which is not correct? I'll bet you this is correct and this is not. And how am I going to know? How am I going to know here? Well, let's try it on the SDR, because the SDR has a big future today when I'm testing the transmitter. I'm just tangled up on my wires here. In case you're wondering why the camera's going around like that. Sit there. Let me fire up the SDR and get it going here. Okay, well, I'm trying the impossible here. I've got I got one of my cats in the shop with me. We'll see how long I can get along without him meowing me into submission. So I brought this radio in because I realized I can figure out with some precision and accuracy too what the transmit frequency is on or the output frequency of the signal generator is, regardless. Hey, I'm going to be able to calibrate this guy finally. So that's step one. And then if we know that this matches this, and we know this tells us what that is, we then, if A equals B, B equals C, then A equals C, then we'll know for sure the frequency over here. Assuming, of course, this is accurate. But I think that's a really good assumption. I think a radio like this is very, very accurate. Yes, accurate's the right word. Okay, so let's turn this guy on. 26,650. But we're actually up around 27015, so I'll put that in. 27015. We're just going to turn the volume down a little bit. It's kind of quiet now anyway. Why is that? Is it quiet because it's picking up the signal generator already? Wait a minute, I don't think so, because you see everything all at once here, because we're at 27 on this. Okay, I'm going to try to avoid stepping in front of the camera, but it's getting a little tough here. So I'm going to tune the signal generator until we hear it coming out of here. And you can hear my cat's voice coming out of it. My cat's on the CB down in my office talking to us. Yeah. So here we are. So 27015 here. Maximum signal here. 27007 here. So this is actually 15. So at 27 megahertz, this thing, I'm 7 or 8 out. Double, triple what it is down around where I usually use it. Okay. I think I got that locked in my brain, at least for the next couple of minutes. Now we also see up on the screen, I didn't mention this, the SDR, the big part of the screen. You can see the CB range. And what all do we see there? So we see something funny showing up just above 27.050. And we also see something at 27.250, just below there. What do you think, Peanut? And the red line is set to channel 20, I think, yeah, I set it to channel 23. So that means everything to the left of the red line is in the range of this radio on my bench, because you can put well, I guess you could actually put crystals in for channels above 23, but at the time this was made, it was intended for crystals that ranged between channel 2, I think, and all the way up to channel 23. Maybe there was a channel 1, I can't remember. So that's what's going on the SDR display. So what I'm going to do is I'm going to boost or move the signal generator. There's zero antenna on my SDR right now too. I'm hearing this. That's better. Okay. Just thinking here, thinking. Oh, Peanut, really? What's up, buddy? You don't want to be in here. You want, yeah. See, we turn to the door. Okay, out you go. I'm learning more and more about how cats communicate, and you know, it's not hard if you just pay a little attention to things like how they throw their head. You know how we do the same thing as humans, right? If we say, hey, it's over there, we not only point there, we tend to throw our head that way in a certain, you know, a certain motion. And you could even in silence, right, just kind of toss your head in a certain way and you communicate to another person. It's something over that way. The cat does the same thing. It does the same thing. It's just we are so caught up in verbal communications. We're not paying as much attention to the nonverbal stuff. So now when I ask my cat what he wants, I watch really carefully for how he throws his head, because I know for sure he understands English. Okay. So we've got this now set, we know for sure, on channel 5. I see this has gone just a touch low. Is it showing up on this radio? It's right there. Now, I'm going to vary the signal generator a little bit. I'm going to listen to this guy and see if it goes up or down. Now, we could even make this a little more legitimate, a lot more legitimate, if we just turn on a few more meters here. Let's turn this one on too. It's a cold day, you know, I can use more heat in here anyway. So this is showing AVC. Let me turn this down. This is showing AVC, and this is showing audio level. So let's check the audio level first and see if that's true. Yeah. Very sensitive, isn't it? That's excellent. That's just what I want. The AVC is sitting over here on the 15 volt scale. We're looking at 3 volts of AVC. If I remember right, this can go all the way up to 33 volts with a strong enough signal. It's a huge AVC swing on this. Yeah, most radio AVCs go from a couple volts or something like that up to maybe 15. Not much more than that. So right, I'm going to vary the input frequency or the transmit frequency, and we're going to watch this meter. I sort of forgot once again what I'm doing. Here we go. Does it go up or does it go down? That's the question. And where is it? Let me just set it right on, make it easy for me. I'll set this right on 3 here. Oops. Just moving the volume control. There, it's right on 3 now. Here we go. It went down. Get back. Does it go above 3? Oh. This is so... It does go above 3 a touch when we're up below the frequency ever so slightly. Okay, so what happens if I move this to where it should be? There. So we know now this is actually 015. This is sunk down a bit, suggesting that it's not right on. It's time to try the alignment thing again. And see if this time I can see the change the way I expect it to change. Okay, is everybody stable? This is still right here. Yeah, a little hard for you to see, I know, but there's only so much I can do here. Okay, getting on what I think is the correct spot. Okay. Now, watching the audio meter here. Turning. Oh, it fell out. There's more adjustments right in this area here. I may be on the wrong one. Turning. It's bad news, eh? It's not doing a darn thing. It's going down. No, it's really not doing anything. I think I may have grabbed the wrong adjustment. So that's bad news. The thing I'm turning didn't do anything. Maybe it's part of the transmitter alignment, or maybe I'm just totally mistaken. Now let's see if we can get this onto the SDR. To check the SDR calibration. So I'll throw a sort of a pseudo antenna onto it. Find something, just a clip lead here. And I'll just leave it laying over here somewhere. And I'm going to put this on the SDR antenna input. Watch the SDR. Well, we can guess. We don't have to guess. It should be 27015. That's this bright line over here, I'm sure. Let's measure its frequency here. Okay, so if you look very carefully right in here, you'll see it ever so slightly off. It's a tiny amount, moving 1,000 hertz at a time. Not sure the accuracy of this. If you look over here in the control panel, we find stuff like shift. So there's no shift inputted here, but the shift is to shift the radio onto frequency because it's not dead on. But this signal here has to be 15. You know what? This could be out by a touch too. Even though I tried my best, it can easily be out. Well, I think the conclusion here quite clearly is this radio is tuning in channel 5 properly. It's not surprising to me that my conclusions in the last session may not have been quite correct. It's also easy for me to believe the crystal is still bang on after all these years. So let's go up and try the other one, because the other ones really seem to not come out correct. So we'll go up. So this is now supposed to be, I think it's 13 and 15. It seemed to me it was 12 and 16, in fact. But let's try it again. So if this is channel 13, I'll check the chart here. Just bear with me quickly. Channel 13, the frequency is 27115. 27115. 27115 is so that's channel 13 there, where the red line is. So let's go up there with the transmitter. 27115. Actually, I'm going to set this radio to 27115. One, 1, 5. Okay, now we'll move the transmitter or the signal generator frequency up there. Well, this is proving pretty clearly that this radio is tuning exactly the same as this radio, because this level is coming from this radio. The sound you're hearing is mostly coming from this one. That's me on the volume control. Oh, you can see my hand. Good. So that proves that this is really channel 115, which is channel, I gotta double check here. 115 is channel 13. It really is channel 13. That's right, that's what it's supposed to be. Regardless of what happened yesterday. We check the last one. We do it the same way using this radio again. So this is supposedly channel 15, 27135. 27135. 27135 here. One, two, four on the counter there. 124. But it's definitely 135 down on the radio. And quite clearly, as the signal was coming in here, Peanut, come inside. Come back in. Poor cat. He really wants me to go out there and spend some time with him, so maybe I would just stop at this point for now. Conclusion: reception in this radio is right on target. When I flip to the channel number on the front of the radio, I am selecting that channel for sure. It seems to be tuned right in the middle. It all makes sense. So I think I'll settle for that. Probably the transmit side is going to be just as good. It's crystal controlled too. My cat is not crystal controlled though, so I gotta go settle him down. He's okie dokie. So I think we're ready to try transmitting with this. A long time ago I transmitted with this without doing any checking at all, just a long time ago, and it did definitely transmit. So, but what exactly is going to come out that antenna, I'm not so sure. So I got to think of a few things here. There's a few issues with doing this. One is the antenna sitting right here. It's right here, right near the radio. The radio does not have its cabinet on. Its cabinet is all metal. So there's a metal shield over top of this entire radio that's missing right now, and the antenna is sitting right there. Of course, the transmitting signal is traveling on wires right inside the radio too. Shielded as they may be, probably no concern with having the antenna so close. After all, think about walkie-talkies. So it's probably no concern for that. Number two, the antenna is close to everything else in my shop here. So I'm going to be putting out some amount of signal out of that antenna. At most, if the radio is working the way it's intended to work, I think it's 4 watts of power will come out of that antenna. What does that mean exactly? I don't know. Does that mean it's going to energize any resonant thing here in my shop? Anything that's resonating at 27? You know, if it were 100 watts, I would fill my pants thinking about doing this. It's not. It's 4 watts, and it's probably 2 watts. It's probably what's going to come out of here. A brief shot can't do any harm, I don't think. So now we've got 2 or 3 receivers in here operating. Got this guy, he's turned off at the moment. And we've got the CB radio on the wall over here, dialed up to channel 10. And then I have my SDR with this antenna, sort of antenna hooked up. I'm going to take this off now just to reduce the signal input to the SDR, because I think we're going to want to see what this looks like on the SDR. Now, next thing is audio transmit level. There's no microphone volume control here. I doubt this one is affecting the audio level, but it might be. So maybe you have to turn this up. I doubt it. Chances are this is just set the way it's set, and so when you push the button, actually you need to pull the button down, there is no way to control the level between the microphone and the... So that means feedback is really very, very likely in here. Unless I can do this, I can do this. That would reduce the feedback. That's probably pretty effective, in fact, doing this. So when I go to transmit, I'll make sure my hand is over the microphone to try to reduce any feedback that might happen. Because with a fairly strong signal, even though my walkie-talkie is set to channel 10, it may still react to this this signal. I mean, I think it almost certainly will. So where's the volume on that radio? Good question. Let's find out here. I'll just turn the squelch off. So not very loud. And we'll squelch it fairly high. It'll only react to a fairly strong signal. I'm sure that's coming from this thing. Next thing is this radio down here. I'm just going to keep it off. The only other radio then will be the SDR with no antenna except for whatever little lean wires are coming here and that. So then we need to have the SDR on the screen here. Let's do that. Okie dokie. Good. So when I push the transmit button, what do we want to be looking at mostly? Not too worried about this. Not too worried about this meter either. I think really it's watching the SDR and seeing where a signal pops up. I don't think there's anything else really to worry about. Now what about the radio itself? Transmitting with the radio itself. Hey, good thinking. Glad I did that. First I should switch it to antenna. So now it's receiving the signal generator on the antenna. I'll switch to our channel 5. I'm going to throw this off here. Oh my gosh, I just initially threw it right on the channel 5. So the signal coming out of here can't do anything. It's only going to this switch box and then dying there anyway. I got this guy in the circuit. Hey, let's do this. Let's put this one in the circuit. Yeah, let's do that. Now these SWR meters need some calibration. The calibration is around getting it to accurately read the SDR, the SWR, too many. What does TLA stand for? TLA, 3-letter acronym. What does ETLA stand for? Extended 3-letter acronym. So like I say, these things need some calibration, and at the moment I don't really know how to do it. It's got a modulation setting, that's interesting. SWR and RF power. And calibrate. Probably calibrate SWR. Probably calibrate modulation. I don't know. We'll put it on RF power on here now. So you can kind of see there's a red area, and the red area is where the watts go above 2. It's actually, the red area is more about the SWR being too high. The standing wave ratio. That's the amount of power making it to the antenna versus the amount of power that's just knocking about in the transmission line and being dissipated by the radio itself unintentionally. So really, this radio, if it's working properly, should push this pointer. Can you see this? Very hard to see. Should push it all the way up to 4, about halfway into the red here. Accuracy of this meter? I doubt it. But we should see something on it, I imagine. Okay, we got everything ready to go now. So we're gonna try to watch this meter, and let's fix up the camera shot here. It's really the only thing that's really of interest is what's on this meter, I think. And you want to be able to see what I'm monkeying about with on the radio. Okay, so we're on channel 5. We'll transmit and spot it on the, just transmit very briefly and spot it on the SDR. There we go. Okay, so that sound came out of the speakers in my shop. So what's happening there is the radio transmission is being rectified. This is what I think is going on. It's being rectified within the amplifier, probably the final transistors. Feeding my little shop speakers here, which you guys never hear, but they're way up here. They're way up here. And there's one there with sunshine on it. That's my grandparents watching me there. And see, I'm not alone in here. grandparents with me. Okay, think now. So we'll just turn off those speakers. I'll get rid of that sound. Okay, let's try again. You ready? Here we go. Well, you can see a dot traveling downwards on the waterfall display. That's marking the frequency of the transmitter. So let me hit it again, and then I'm going to measure that dot. Okay, right in here, right there. 27005. It's supposed to be 27015. So is my SDR out? The best way to do this now is to calibrate the signal generator using the little radio to the transmit frequency, which is the same as the receive, 27015. And once we know this is 27015, we will then see it on the SDR and be able to calibrate the SDR. So bring back the radio. Double check channel 5 before we get into trouble here. Channel 5, 27015. No doubt about it. 27015. 27. It's particularly quiet on this channel. This frequency. Why would that be? I'll change the radio here. What's going on at 2715? I don't know why it's doing that. Okay, we'll just ignore the fact that this seems to be a little bit quieter. It seems to be picking something up. Okay, so we'll now tune the signal generator to match this. Right. Hopefully it'll pick it up pretty easily. See, and you hear that heterodyne? The heterodyne tells you there's another signal here at 27015. It's definitely, based on earlier calibration, this is definitely 27015. Okay, we'll shut this guy off. I don't know what the other signal is. Maybe we'll pursue that in a moment. And then we want this to show up on the SDR. I want it to show up there. Is it already there and I don't realize it? I don't think so. So in order to encourage the signal to make it to the SDR, let's see, the best thing I can do is put that temporary antenna on the SDR. Pick up this weaker signal. One of those. I'll put this near the near what's all that stuff? Yeah, there isn't any one thing really standing out here. This should be, well, it should be just above the red line, and there is something there. Is that 27115? 27015? Not really. Way over here. Or the calibration of this is out. So we'll listen to these and I can identify them. I have to turn my speakers back on. That's pretty quiet. Oops. Just getting the red line right on that peak there. Not hearing much of anything. Okay, now my signal generator is modulated at 30%, 1000 hertz. 27015. We should hear it. We should hear that. The reason we can't hear is it's just not strong enough yet. Let's do this. There we are. Now we hear it. And now we see it. And now you can see I'm tuned right into it. 27014. So that would suggest, if we go to 15, it's just off a hair here. So assuming again the little gray radio is a proper standard, and I have no reason to doubt it, then we've now got the SDR properly tuned to 27015, even though it says 14, where the red line is. Well, that should be where the transmitter transmits, right where that red line is, on channel 5. So again, are we ready now to try transmitting again? Where are we at? I have an antenna hooked up. I got to take the antenna off the SDR. That's just for fear of just blasting too much signal into the front end of the SDR. We're hooked up again to the antenna. Okay, a little blasty. He says just a hair below, right? See a couple other things showing up. Not sure what to make of those other dots on the screen. Could be SDR overloading. Could be all kinds of stuff. Not to suggest it's necessarily coming out of the transmitter. So that was 5, and let's do it once more. Oh, you know what? Just let me just try this. I'm going to turn this guy back on. So what I'm going to do is a series of transmissions from here. I'm going to watch and listen to this radio. I'm going to change its frequency one kilohertz at a time, and we'll just see if this isn't the maximum spot right on 27015. I just noticed I never noticed the power meter's going up. We're cooking with gas here, so turn down. Oh, I got the speakers on again. That's what I'm hearing. Okay, speakers off. That's a cheap untuned radio. That's what that is. This isn't even reacting. Yeah, this doesn't seem to be working at all the way you would expect. Put this back to 27115, where there's a carrier sitting here. Who's transmitting? Who's doing that? So with this carrier sitting here, right on channel 5, I can't see the effect of the other transmission. I can hear it, but I can't see it. I'm going to turn off the radio for a minute and see if this disappears. Where is it coming from? Well, it's not coming from the CB. Who's transmitting on channel 5? Well, isn't that the greatest mystery going? Let me turn off the walkie-talkie over here. Okay, so it's off. Still here. You know, you just never know what the complications are going to be. You have a mysterious signal. And this radio's picking it up, but I don't really make out that there's something happening on the SDR. There's no antenna again. No antenna on the SDR. Let's stick it back on. What shows up? Well, see, now there is something showing up right in there. Well, you know, when you look at the SDR, you see the repeated signals on it. There's something in the house here that's blasting out an interference signal, and one of the harmonics, if you want to call it that, shows up right on channel 5. Just a bad coincidence. So what am I concluding here? Channel 5 appears to be channel 5. Let's go then to channel 13, and we'll transmit again on 13, and we'll see where that shows up. Let's just hit the button here. It's quite clear where it shows up. I got the antenna on. Shame on me. Let's take it off quickly before those disappear off the screen. Just a little bit right about there. And what frequency is that? It's 27112. And now we'll peek at the chart. 27112. So then 27115 is 13. And that's where we are. Well, if it's a little off, it's a little off. It's not far off. At this point, I feel pretty reassured about that. Okay, 15 on the transmit. 15 on the 15 on the transmit. Okay. There we go. There it is. Quickly get that guy. Just a little bit lower than that. Be about there. 27134. Go on the chart. 27135 is 15. So what I'm concluding here is the radio is working on the proper channels, the ones that the crystals are for, and it's pretty much dead center on the money. Can I improve that at all? I don't know. So far, no. No would be the answer. But then maybe I've been doing something a little wrong in my efforts to align this radio. So we've also discovered that it's putting out enough power to make this meter go up. Let's see if we can't detect or measure or get some feel for what kind of SWR there is. SWR is an issue with a radio like this. If you transmit for a duration and the SWR is very high, you're going to overheat the output. Now this is a tube. This is a tube radio. It's not the same as a transistorized guy. The output of this is much more rugged, as my understanding. And so SWR problems and that, not quite as critical as with a transistorized guy. Now, if I got this thing all hooked up correctly, the answer would be, yeah, I think so. Let's just take this off. Yeah, too many extraneous leads in here. A little too much for my eyes to look at. Should there be an emergency, you have to know clearly which way to run. So, okay, so we're going to look at the power that's coming out of this thing on here. And you know what I'm going to do? I'm going to turn the two calibration controls down. We're going to watch the power reading, and I'm going to turn them the other way, watch the power reading, and we'll see if in fact those calibration things have an impact. So here we go, just brief transmissions. It comes right up to 3.5 watts on here. Calibration, turn right down. Turn it right up. Exactly the same. So calibration control is really for calibrating modulation and calibrating SWR. Calibrate SWR mark is there. So we'll put this on calibrate. We will key the transmitter. How do you like that? Key the transmitter. And we will then adjust the calibration quickly. And here we go. Okay. Next thing, we should be able to get a SWR reading. That was pretty bad. And it doesn't get much worse. So what that tells me is under this arrangement, if you believe this meter, if we believe everything that's going on here, very bad to transmit an extended period with ye old radio. Brief shots, not going to hurt. Why so bad? I don't know. I really don't know. Have I done something really stupid here? No, I don't think so. I think it's... Hey, let's try another meter. Yeah, when you don't like what your meter says, get rid of it, get another meter. Keep doing that until the meter shows you what you want to see. That sounds like a real scientific way of doing things. So this one, field strength SWR tester. Switch up calibration field strength, switch down SWR. There's no calibration thing. So SWR on here is so field strength is at the bottom here, 1 to 5. Then it says percent reference power. Seems to be indicating this lower scale. Can you see that? Lower scale. Upper scale. Field strength. Field strength's a little different than power out. Field strength. So we're on SWR. It looks like there's no adjustment. Let's just hit it. So it's going right off scale. That sounds bad. I think typically SWR of 3 is really presenting it's really telling you you got big problems. You know, if you're reflecting power back, it's not going out the antenna also. So not only are you cooking up your radio's final output, whatevers, you're also not getting any signal out. What am I going to do about this? Dummy antenna. Dummy antenna. Dummy antenna for a dummy technician. Where's my dummy antenna? I got it laying around, right around here. I have a cheapo dummy, and then I have a much, much better dummy antenna. Here it is. Okay, so this is my dummy antenna. There's a fairly large wattage resistor actually installed right inside this. 50 ohm resistor. So we're going to replace the antenna with a 50 ohm resistor. Goodness knows what will happen with this. Okay, so we're still on SWR. There we go. Oh, my. That's interesting. So we no longer have this SWR just going wild. I should really do a couple more things here before we conclude. I'm going to hook the antenna straight up to here rather than have it go through this switch. So this is important for me to do for continuing work on the transmitter. I've got to know I can transmit safely with it. It's not as bad. So this box was not helping. This is still on SWR. SWR going just a little into the high side according to this meter. You could even run into problems with using critical length leads in here without realizing it. I think these are all really short, so I don't think there's a problem. But doing this kind of thing, if you just happen to pick just the wrong size something, the wrong length of wire at some point, I think it can cause you a lot more headaches than you might imagine. Talking about imagine. I imagine there's a coil inside here. that is somehow fixing this antenna. It has a very short whip on it. I don't know that for sure. So we're ready now. RF power, we know the calibration things don't mean anything. Straight into the antenna. What do we get? We get 1 watt on here. Okay, and where's the hum coming from? Coming out of another radio I left on here. Let me turn off this other one, because let's try it now. It's still humming out of the speaker. Well, it took a little while for that radio to actually shut off. Okay, so we'll try SWR. Calibrate mode. Calibrate here. Calibrate. It can't get there. SWR. Way off the scale. This meter says it's right off the scale. Calibrate, can't quite get there. Right off the scale, and the power is only 1 watt. You know, that thing about the guy with 2 watches never knows what time it is. Well, the guy with 2 SWR meters, he never knows what his standing wave ratio is. Am I putting this on right? Transmitter, did I put this one on right? Transmitter. Antenna, yes I did. They're both the same. Straight to my antenna. I'll try the field strength thing next time. Okay, so looking at SWR. So it goes 1, 1.52, 3, and then a little ways away it says infinity. So it could be that 3 to 4, 5, 6, 7, 8. And this one on SWR, well, it's kind of similar in a way. It kind of just doesn't even report after 3. Kind of the same as this. Of course, they're made by the same company, right? Let's try this field strength thing. I have no idea what I'm doing. Calibrate? What are you calibrating against? I have no idea. Because this is suggesting there's 1,000,000 watts coming out of here. So I don't know what field strength means. It's not the same as RF power, I don't think. Okay, what's the result of this? The result of this is I'm not terribly comfortable. Oh, wait a minute. Let's see if I can become terribly comfortable. SWR. Look at that. So in this mode, yes, I don't know what this means, but like this, the SWR is excellent. What that's telling me is all the power being delivered, being produced by the radio, is being consumed in the resistor here. 3 watts would take a while to heat that guy up. Anything bad happening anywhere? You can also see the transmitter is dead on, 27,134 on the SDR. Looks like a nice clean output too. Okay, we get any heat in this thing yet? No, nothing whatsoever. So 3 watts, you know what, like a night light is 4 watts. So 3 watts. Take a while to warm up the room with 3 watts. So all in all, I think, like, keep a meter like this in the circuit. Use a dummy load here. No longer any problem with SWR. Any power coming out is being consumed over here. The radio is now comfortable. I'm comfortable operating it like this. So we can start doing various kinds of transmitter stuff. As for the antenna and why my antenna botched so badly, this thing here, I came in here, I committed an evening, well, not a whole evening, to fixing this guy up. And he's let me down. It could just be, look, it's in here with all this metal all around it. It's just not where it's supposed to be. We won't worry about that because for now we can continue doing work on the radio using this setup. And then we have this one, just if you want to add confusion, we can add this one. I can probably chain these in series. Get them both going. Why not? Okay, power off on the radio before I forget. And I think that's it for today. All we learned is receive and transmit appears to be, on a rudimentary level, really, really good. Seems really, really good. Just need some skip now and talk to somebody in South Carolina. Thanks so much for watching, and I'll see you on the next video.